Alright, so the first question, part A said, express this as a single fraction in its lowest terms. Alright, so when you look at this expression, it's made up of two fractions, and these two fractions are subtracting. So what you have to know is that you cannot add or subtract fractions unless those fractions have the same denominator. So when you look at these two fractions, they have different denominators. So your job is to make sure that these fractions have the same denominator. And we are going to do that by using the concept of equivalent fractions. All right, so let's just rewrite this expression. So we have 6 over x minus 2 minus 2 over x minus 4. All right, so our aim is to make the denominator to be the same. In other words, we are finding the common denominator. So how are we going to do that? So what we're going to do is that we are going to multiply this denominator of the second fraction by the denominator of the first fraction. So what we are saying is we are going to multiply this denominator by the denominator of the first fraction. So we're going to have x minus 2. Okay, so because we are using the concept of equivalent fractions, what we have done on the denominator of this second fraction, we also do it on the numerator. So this also is multiplied on top there, like that. So that the value of the fraction remains the same. If this and that cancels, you still remain with your odd fraction. So again, we are going to multiply this first denominator by the denominator of the second fraction. Okay, so this is what we are going to do, x minus 4. Then what we have done on the denominator, we also do it on the numerator so that the value of the fraction remains the same. So x minus 4. All right, like this. So what we are going to have now is 6x minus 4 over x minus 4, x minus 2, then minus this, which is 2, x minus 2, x minus 4, x minus 2. All right, you can see that we have the same denominator on both fractions. We have this and we have this side. So because of that, it means that these fractions can now be subtracted directly, or you can carry out your subtraction direct now. So what we're going to do, since they are the same, we're going to pick one of them. So we'll pick one of them, x minus 4, x minus 2. Then we pick these as they are. So we have 6, x minus 4, minus 2, x minus 2. So the denominator will remain the same. So we have x minus 4, x minus 2. So let's expand and simplify. So we have 6 times x is 6x. Then 6 times negative 4 is negative 24. Then you come to this part. Negative 2 times x is negative 2x. So take note, I'm saying negative 2 times x. I'm multiplying together with a sign so that we don't make mistakes. So negative 2 times negative 2 is positive 4. So we collect like terms together on top, but on the denominator, we're going to remain with x. We'll maintain the x minus 4, x minus 2. So this term has an x and this term has an x. This is positive and this is negative. So we're going to say 6x minus 2x is 4x. Then negative 24 plus 4 is minus 20. So this expression cannot be simplified further. So meaning you have written this as a single fraction in its lowest terms. All right, question B says evaluate. So they want you to evaluate this integral. And remember, because this integral has limits, then it is a definite integral. So this integral we can rewrite it as the integral from -3 to 2. Then this 4 has no variable, is not carrying any variable. So we're going to say 4, because this is x, we are integrating with respect to x, we're going to give it x as well, but to the power 0. Remember, any number to the power 0 is 1. 1 times 4, it will come back to 4. Okay? Then minus 3x squared, then dx. This and this are just the same. Okay? So now, to integrate means you need to add a 1 to the power and then divide by the new power. Okay? So what we are saying is we're going to have 4x to the power 0 plus 1 over 0 plus 1 minus 3x squared plus 1 over 2 plus 1. Then we are integrating from -3. The limits are from -3 to 2. All right, let's just simplify this. So we're going to have 4x, 0 plus 1 is 1. And the x to the power 1 is just x. Then over 0 plus 1 is just 1. Minus 3x, 2 plus 1 is 3. Over 2 plus 1 is 3. Then we are integrating from -3 to 2. Let's simplify further. We are having 4x, because 4x divided by 1 is just 4x, minus this 3 and this 3 are cancelling. We are going to remain with x to the power 3, then from -3 to 2. So now, since we have integrated, we are going to replace the upper limit first. So make sure that you get this right. You substitute the upper limit first in here. So we're going to have 4. Where there's x, you replace the upper limit, which is 2, then minus 2 to the power 3. Then minus 4. Here now we're going to replace the lower limit, -3, minus -3 cubed, like this. Okay, so now 4 times 2 is 8. Then minus 2 cubed. 2 cubed is also 8. Minus 4 times -3 is -12. Minus -3 cubed is -27. So this 8 minus 8 is 0. So you have 0 minus -12. The negative times negative to be positive, +27. So what we are remaining with is, because this is 0, we are going to remain with minus. So -12 plus 27 is +15. So a negative times +15 is -15. All right, so we're going to conclude and say, therefore, the integral from -3 to 2 of 4 minus 3x squared dx is equal to -15. So that's it. So if you have me up to this point, it means you are enjoying what I'm doing. Please consider subscribing, hit the like button, comment and share.